Today we're going to be looking at how to add vectors that are off axes. And there's a couple things we need to know based on our previous lessons coming into this. We need to be able to assign a frame of reference. We need to be able to calculate the components of the vectors. Especially if a vector is off axis, we need those components to be able to add it. And then we need to remember how to add components. So once we have our final components of the vector, we need to get our overall resultant. Let's look at an example. Let's take a look at an example adding vectors together. We're going to add two vectors and express the resultant. First vector I have is 37 meters with an angle of 55 degrees. And then I also have a vector of 50 meters and an angle of 12 degrees. And this 12 is referencing that angle right there. Just like always, first thing I need to do is define my frame of reference. I'm going to use the standard positive y up, positive x to the right. And then I'm going to break my components of each of the two vectors. I'm going to do the horizontal component in blue, and let's do the vertical component in green. Thinking back to our first lesson, we have SOHCAHTOA. We know that the sine component is the opposite component. The cosine component is the adjacent. So I take the magnitude, which is 37, and I'm going to multiply that by the sine of the angle, which is 55 degrees. 37 sine 55 gives me a magnitude of 30 meters for the vertical component. And I'm going to do the same thing. 50 sine 12 gives me a magnitude of 10 meters, on the vertical component of the other one. And then I do the same thing for the cosine component. 37 cosine 55 gives me 21 meters, and 50 cosine 12 gives me 49 meters. Now that I have the components broken apart, I can start the adding process. To do that, I'm going to add the x components together, and I'm also going to add the y components. We'll call our resultant vector vector r. So we're trying to solve for vector r, what we get when we add these two things together. Looking at the x, I see both of my components are in the positive direction. So the x component of vector r is going to be equal to those two values added together, or 21 meters for the first one. And since 49 is in the same direction, I add 49 meters to it, which gives me a total x component of 70 meters. And then for the y component, I notice I have two going different directions this time. I have one going up, and I remember I've defined up as positive, so I'll go ahead and list it first. So I have 30 meters as a positive number, and then I'm going to add the other value, but since it's pointing down, it's actually a negative 10. Another way you can handle this is simply by subtracting. Some people like adding the negative, some people like subtracting. It really doesn't matter which method you use as long as you're comfortable with it. Then when I add my y components, I get an overall y component of 20 meters. It's a positive number, so I know that it is up. I'm going to go ahead and draw my coordinate system. Since I see both of my components are positive, really the only quadrant I need significant is the quadrant 1. I'm going to start by adding my horizontal component to the axis, and then I have my vertical component. But I remember when I'm adding components, I need to transcribe it, so I'm going to bring that over to the end of the other vector. And my overall vector is the resultant, which I get from starting at the origin and going to the tip of the second vector. We'll go ahead and label my components, y component 20 meters and x component 70 meters. And it does form a right angle. Because it forms a right angle here, I can use Pythagorean's theorem to calculate the magnitude of vector r. I'm going to take 20 squared plus 70 squared gives me 5,300, and then I'm going to take the square root of that, which gives me 73 meters. So the magnitude of vector r is 73 meters, which I'm going to go ahead down here and label as well. But a vector isn't complete just with a magnitude. I also need a direction. And the angle I'm going to choose to reference, I'll label in purple here. And it is this angle right here. Now, I don't want to use rounded numbers. In this case, I'm kind of stuck. But I used the inverse tangent out of habit. And we remember tangent is opposite over adjacent for TOA. So the inverse tangent of 20 divided by 70 will give me the angle. And that gives me an angle of 16 degrees. So this is an angle of 16 degrees above the positive x-axis. So this vector is 73 meters at 16 degrees above the positive x-axis. Now it's your turn to try. Pause the video here in just a second, give this a shot, and then come back once you've tried it and we'll walk through it together. Again, you're going to add the following vectors and express the resultant. Go ahead and pause the video here, come back and try it. Okay, hopefully you were able to work through that. Let's go through it. Again, I'm going to define my coordinate system. Just going to use the standard XY coordinate system. I'm going to break my vector into components. So in this case, both of my horizontal components are pointing toward the left. And then my vertical components, I have one pointing up and one pointing down. And I'm going to add them together. I'm going to call that vector R. Again, first thing I have to do, get my sine and cosine components. I'll go ahead and do the sine components, or the vertical ones first. 34 sine 29 gives me a magnitude of 16 newtons. And then 42 sine 51 gives me a magnitude of 33 newtons. A magnitude of 16 and 33 newtons respectively. Let's get the cosine components. 34 cosine 29 gives me a magnitude of 30. Oops, changed color there. So this one is 30 newtons. And then 42 cosine 51 gives me 26 newtons. Again, I break it into the x and the y because I need to add only those components together to get this to work. We'll start with the x components. So the x component of the resultant, and I can start with either of them. I have a 30 Newton component in the left one. However, since it's pointing to the left, I have to call that negative. So I have negative 30 newtons plus, and I use the other one, which is also to the left, so another negative number, negative 26 newtons. And that gives me an overall x component of negative 56 newtons. And then looking at the y components, I have the one going up and one going down. So the one going up is positive. I like to start with positive numbers. So we'll list it first. So I have 16 newtons plus the other one going down would be negative. So negative 33 newtons. So I have 16 newtons plus negative 33 newtons, which gives me negative 17 newtons. And looking at this, both of my components are negative, which means that quadrant 3 is where my vector is going to be. So when I draw this out, I'm going to make quadrant 3 the largest part of it. The x component is negative 56 newtons, so a little more than 3 times the length of the y component. You'll notice, since I've drawn the direction, I actually don't label the negative on it when I draw it out. Because I'm showing the direction using my axes, I don't have to put the negative there. Same thing when I show my negative 17 for the y component. And I'm going to go ahead and transcribe that over here. And then my resultant vector goes here. So again, I have 56 newtons and 17 newtons for my components. Pythagorean theorem is our friend here. 17 squared plus 56 squared gives me 3,425. Take the root of that, and it gives me 59. Magnitude is 59 newtons. I'll go ahead and bring that down here. So vector r has a magnitude of 59 newtons, and I need my direction. So 59 newtons at, and again, out of habit, I'm just going to use the inverse tangent. Find that angle right there. Tangent is opposite over adjacent. So the inverse tangent of 17 divided by 56 gives me an angle of 17 degrees. So this gives me an angle of 17 degrees, and it is below, in this case, the negative x-axis. So this is below negative, and I like to put my negatives in parentheses so I know that it's a negative. Below the negative x-axis. So our vector r, when we add these two together, is 59 newtons at 17 degrees below the negative x-axis. Good luck. Work through the practice. If you have any questions, please reach out.